This is Amitech VNA Vector Network Analyzer VNA04. After installing the software, connect USB cable to the USB port of laptop and open the software. Now it says, do you want to allow this app from an unknown publisher to make changes to your device? amitechvna.exe. Press yes. Now you will see the GUI opens and automatically the window of live measurements opens up. This is the first row which says File, View, Window, Tools, and in second row it shows live measurement, Smith chart, XYY plot, markers and calibration. Now before trying to operate VNA, which has two ports, port 1 and port 2, we will open the calibration. Now in the calibration window, you can see it says calibration range. I will magnify this window. Now this is the window. Now it says range from 2 GHz to 4 GHz. All our MIC modules will be in this range. Steps, it says 201. Averaging, it says 1. We can take averaging as 5. ADC average 10, let it be there. And it says 2-port SOLT with 1-port calibration kit. There are different options like SOLT with 2-port and others. Let us select the one which is in default, that is 2-port SOLT with 1-port calibration kit. Now in this we will press start. Now it automatically guides you how to do the calibration of VNA. For instance, it says take short reflection S11. This port is 1, so S11 will be on this port. Now it says connect short calibration standard to port 1. Now this is a short, I will connect this to port 1. You have to be little gentle by tightening these ports. Now we will press scan. Now when we press scan, it will start doing the scanning, as you can see, because the average is 5, so it is taking little time. Now to ensure that the VNA is connected, it will display a message here connected to VNA 2.0. So if the VNA gets disconnected somehow, then it will automatically try to establish the connection and no reading shall be wasted during connection or disconnection. Now similarly, once it has scanned, it will guide you to different calibration standards. Like first it says connect short calibration to port 1. In the next it will say connect short calibration to standard to the port 2. Now as you can see, once the scan is over, the stop button has changed to scan and we need to press apply and next. When we press apply and next, as you can see it says connect short calibration standard to port 2. Now we will connect this short to port 2 and then we press scan. So similarly it will guide us to do the calibration after short with open, then load and then finally through. We connected the short at port 1 and 2. After that we connected load at port 1, then at port 2, then open at port 1 and port 2, and as you can see in the software it says calibration 7 of 8. The last step was leave port 1 and 2 open. Now here 1 and 2 open means do not connect any short, open or load on these two ports and leave them as it is. Now after scanning, we will press apply and next. Now this is the 8th step of the calibration. It says connect port 1 and port 2 with through. Now this is the through. This is a through connector. So it says, here it is saying a piece of cable as short as possible and as close to characteristic impedance as possible. Now here the characteristic impedance is 50 ohm and this is a RG316 cable. So it has a characteristic impedance of 50 ohm till 10 gigahertz. The high cost VNA, they use phase stabilized cables which cost around $10,000 and more. So here we will be using RG316 cable. Now we will connect a through load, a through connector or a through adapter here. And after connecting this, we will press scan. Now, if you had observed, when we started this calibration, it said SLOT. Now as you can see, S is for short, L for load, here load means 50 ohms, and O is open load, and through. Through is basically a SMA to SMA female adapter, which is allowing the power to go from port 1 to port 2, and vice versa also, because this is a 2-port VNA where port 1 can act as transmitter and port 2 as receiver, and other side also, that is port 2 as transmitter and port 1 as receiver. So that is why in this VNA we can do S11, S22, S12, that is 1 through 2, and also S21. So this is a VNA, this is a 2-port VNA which has got capability of S12 as well as S21. Now having the capability of both the ports S12 and S21 makes the VNA expensive. Now this process of calibration can be made fast if we had selected this software average instead of 5 as 1 for fast operation, but then it could miss some readings. It is preferred to take the calibration file or load the calibration file every time we operate the VNA. For students level, we can save the file on desktop and load it every time we operate the VNA to save time. Now as you can see, the calibration is almost over. Now it says apply and next. We will press apply and next. Now as you can see, it is showing all the readings here. It says scan complete, simple 2-port calibration. Now we had selected 2 GHz as start frequency and 4 GHz as stop frequency, 201 readings, and reference impedance remains same, 50 ohm. Now as you can see, it has taken 8 and 10 readings total, S11 short, S22 short, S11 open, S22 open, S11 load, that is 50 ohm, S22 load 50 ohm, then S21 open and S12 open. Now this is the capability of this VNA, that it can do S12 as well as S21. Similarly, it has taken S21 through and S12 through. And now we can save the file. Here it says save. As you can see, I have already saved few files, calibration 1, 2, 3. I will mention it, say calibration 4, and I will save this file. Now after saving this file on desktop, this process is complete. I will minimize this window, or rather I will close this window and maximize this live measurement window. Now as you can see, it says from 2 gigahertz to 4 gigahertz. Number of steps 201. Logarithmic, we will not select here this option here. Average 10, and options S11, S21, S12, S22. We will first of all load the calibration, use calibration, and it asks for the file which you have saved here. Now number of different files were made because some measurements we were doing from 10 megahertz to 4 gigahertz, so we had different files. Now calibration 4 is for 2 to 4 gigahertz. I will load this file, and as you can see, it mentions that the scan range from the calibration file was applied. As you can see here also, it says range 2 gigahertz, 4 gigahertz, and this file has been loaded. Now we will select the continuous operation, and before pressing the scan, we will select the measurement. For instance, we want to do the measurement from port 1 to 2. That is, we want to see whether this cable has any insertion loss or this adapter is SMA adapter is good. So we will select here frequency S12, and then we press scan. Well, it says select any transmission mode please. So again we have to go back and select S12 here. So now as you can see, we have to select S12 two times, first here and then here. Now it is very important. Now the scan button is operational. I will press scan. Now as you can see, it is scanning from 2 gigahertz to 4 gigahertz and taking readings which appears to have lots of standing wave or flatness issues. Now these issues are because the reading that we are taking, the scale is 0.2, which is very, very fine scale. So we will use the cursor scroll feature and we will scroll it. Now as you can see, the scaling is changing, and now it is 0 to 10 dB. Again, now it says 0 to 20. I can take the 0 scale up. Now this is a 30 dB scale. Here each division is 10 dB. And this is the flatness of this adapter. Basically, we had just calibrated this adapter and stored the file as through calibration, and we are kind of recalling this same file again. So we are retrieving the same file. Now when we disconnect this through, now this is a moment of disconnection.